Okay, so here we're going to have a different type of a 3 by 3. So our first 3 by 3s we did, they already gave us one, and then we plugged in to find the second, right? This is going to have a little bit more work because it's not going to work like that, okay? So this is one of those situations where we look at the explanation and we go, oh no, and then once we do it, it's okay, okay? So the first thing we're going to do is we're going to number our 3 equations so that we can keep track of everything, okay? And then we're going to pick a variable to eliminate. We're going to eliminate it twice using 2 separate equations, okay? And we're going to number those results 4 and 5. Then we'll be down to 2 equations and 2 variables that we can use to solve, and then we'll back solve and plug in like we've been doing, okay? It sounds harder than it is. Let's go. Okay, so first thing, I'm going to number these. I'm just going to say the top one is 1, this guy is 2, and this guy is 3. So now I'm going to look and I'm going to decide which variable I'm going to be eliminating, okay? And I think I'm going to eliminate y. It doesn't matter which one you choose, okay? So the next thing I'm going to do is I'm going to pick 2 equations to use to eliminate y. And it looks like if I use 1 and 3, y goes away really easily, right? So I'm going to use equation 1 and equation 3. I'm just going to rewrite them. So I have negative x plus y plus 3z is negative 3. And I have 3x minus y minus 4z is 6. So I'm going to add these guys together. And I'm going to get 2x minus z is 3. This is equation 4. I picked 2 of the long equations to use to get rid of y, and that's my result. Okay? Now I'm going to pick 2 different equations to get rid of y. This time, I think I'm going to use 1 and 2. To get rid of y? To get rid of y again. So, I'm going to use 1 and 2. So, let's see. 1 is negative x plus y plus 3z is negative 3. And 2 is x minus 2y minus 2z is 8. Now, I can't get rid of y yet, right? Now, I know that I could add those together and get rid of x, but that's not what I'm trying to do, okay? I decided at the beginning I was going to get rid of y, so that's what I'm going to get rid of. So to be able to get rid of y, I need to multiply this equation by 2, correct? So I'm just going to do that. I have negative 2x plus 2y plus 6z is negative 6. And I still have the bottom guy. He didn't change, right? He is still x minus 2y minus 2z equals 8. So now I can add these guys together. And I'm going to have negative x plus 4z is 2. And this is equation 5. So we decided we were going to get rid of y. We could have chosen any variable, okay? I picked 2 equations to use to get rid of y. That's equation 4. Then I picked 2 more, just not the same 2, right? To get rid of the same variable, y, and that result is equation 5. So now what you have is 2 equations and 2 variables, right? So let's look at 4 and 5 together. So 4 is 2x minus z is 3. And 5 is negative x plus 4z is 2. So I want to solve this system. And I can solve it however I want. I could, if I wanted to, multiply the top equation by 4, right, and eliminate the z. But it's actually easier to solve this guy for z. So z would be 2x minus 3, right? If I add z to both sides and then subtract 3 from both sides. So then in equation 5, I can replace z with its value, which is 2x minus 3. And then this equals 2. So I've got to distribute. Now I just have a regular old equation, right? So I have negative x plus 8x minus 12 is 2. So let's see, combining my like terms, I'm going to have 7x, adding 12 to both sides is 14. So x is 2. Now that I know what x is, I can go up to z, right? Z was 2x minus 3. So that's 2 times 2 minus 3, which is 1. And then I've got to find z. I can go anywhere I want to find z. I just found z. Sorry. What do I need to find now? Y. So we'll go into one of our originals. Doesn't matter which one. I'll just go into one because it's right here. And it is negative x plus y plus 3z is negative 3. But we know that x is 2. So negative 2 plus y plus 3 times z, which is 1, right? Equals negative 3. So y plus 1 is negative 3, and y is negative 4. So my solution is the ordered triplet 2, negative 4, 1. X, Y, Z. Tedious, not hard. Okay? Tedious, not hard. Follow the steps. We're going to do another one. All right. First step is to pick a variable to get rid of. I don't like the looks of y because we've got a 3, a 2, and a 4, right? So I don't want to get rid of y. I say let's get rid of x. Oh, we need to number our guys here. 1, 2, and 3. So first, let's use 1 and 3. So 1 is x plus 3y minus z is negative 3. And 3 is negative x minus 4y plus 3z is 6. And I can get rid of it pretty quickly, right? I don't need to multiply by anything. I'm trying to get rid of x, and the x just goes away when I add here, and I'm left with negative y plus 2z is 3. And that is equation 4. Now I'm going back up to my original guys and picking 2 other equations to use. I can't use 1 and 3 again, because if I did, I'm going to get the same equation again, right? So I've got to use 2 different ones. Let's use 1 and 2. I chose 1 and 2 because the signs are different, so I don't have to worry about multiplying by a negative. So 1 is x plus 3y minus z is negative 3. And then 2 is negative 2x minus 2y plus z is 8. So to be able to get rid of x, I'm going to have to multiply the top equation by 2, right? So I'm going to have 2x plus 6y minus 2z is negative 6. And I didn't change the bottom one at all. So negative 2x minus 2y plus z is 8. And so now I'm ready to add these guys together. My x's go away, and I have 4y minus z is 2. And that is equation 5. So now let's put 4 and 5 together so we can see what we're dealing with here. 4 is negative y plus 2z is 3. And 5 is 4y minus z is 2. Now, if I wanted to, I could multiply the top equation by 4 and eliminate, right? I could multiply the bottom equation by 2 and eliminate, or I can just solve one of these for a variable. If I solve the top one for y, I'm just going to switch sides, right? The y and the 3. So I'm going to have y is 2z minus 3. Right, I added y to both sides, subtracted 3. Now that I know what y is, I can plug it into 5. So 4 times 2z minus 3 minus z equals 2. So distributing the 4, I'm going to have 8z minus 12 minus z is 2. It's coming out to the same as the last one. 8z minus z, 7z is 14, right? We'd add 12 to both sides, so z is 2. Now that I know what z is, I can go back up and plug it in and find y. 2 times 2 minus 3, which is 4 minus 3, which is 1. And then to find x, I've got to go back up all the way to the top. I can use whichever equation I want. I'll just use the top one. So let's see. We're trying to find x. plus 3 times y, which was 1, minus z, which is 2, equals negative 3. So we have x, let's see, 3 minus 2, so plus 1 is negative 3. We would subtract 1 from both sides, so x is negative 4. So your ordered pair is negative 4, 1, 2. Not hard, tedious. There's lots of places to make a mistake, so just go slow. And again, follow the steps. What did we do? We labeled our first 3 equations, right? Then we pick a variable to get rid of. Doesn't matter which one. Then use 2 equations to get rid of that variable. Eliminate it. That's equation 4. Use 2 different equations to eliminate the same variable. That's equation 5. Then use equations 4 and 5 to solve, right? And the hope is that that one of them you'll always be able to solve for a variable, right? If you couldn't, then you just eliminate a variable the same way. Okay?